first thing we're going to talk about in this video is an increasing function. What do we mean when we say a function is increasing? Well, it means it looks a little bit like this. So got some pair of axes here, and it's increasing if at every point we have a positive gradient, or it could be equal to 0, a non-negative gradient, if you will. And formally, we say that for all a greater than or equal to b, we have that f of a is greater than or equal to f of b for f. And then f is increasing. And what this basically says is that when you have 2 points, A and B, so A could be here and B could be here, so that A is greater than B, A is further to the right than B. We also have that the function of A is greater than the function of B, so evaluated at both points, the function at this point is actually greater. So for this example here, you've got A being greater than B, but also A is higher up than B on the graph. And that's because f of A is greater than f of B. And we say that the function is increasing if this is true for all A and B. So for every arbitrary pair A and B, we have this property. You can probably work out what a decreasing function is. You say that for all A less than or equal to B, we have that f of A is less than or equal to f of B. So that's just the same as saying, so this should say, that should say A greater than or equal to B. So for all A greater than or equal to B, f of A is less than or equal to f of B. So that's this sort of looking function. So where we have A greater than B, so A might be here, B might be here, and the function evaluated at A is less than or equal to the function evaluated at B. That's all it means. It's basically the opposite statement of this. Notice that a function can be increasing and decreasing in the case that f of A is equal to f of B at all points, but in this case we just have the constant function. Like it's not interesting at all. So that's the only case where we would have it being increasing and decreasing. Otherwise, functions are increasing or they are decreasing, but it's worth noting that they can be increasing at certain points and decreasing at other points. For example, in the quadratic function, it looks a little bit like that. Notice how in this half, so in this half of the graph, the function is decreasing, and then in the other half it's increasing. So then we say it's decreasing over a certain range and it's increasing over another range. The definition of continuity is a little bit hard to explain without having previously introduced limits. However, we will have a go at it and we will just kind of define it visually. We say that a function is continuous. You know, you might have some weird wiggly function here and drawn it to look continuous. And what continuous means basically is that it is smooth. So we've got a smooth curve, which means that we don't have any kind of jumps, like we don't have any of this or that, none of this jumpiness. So if you can get arbitrarily close to some point here, so you get arbitrarily close to it, then if you go in the other direction, if you go in the codomain, you also get arbitrarily close to it. And that's all continuous means, really. In this case, we've talked about a point being continuous. A continuous function means that every point in the function, every point in the domain gives us a continuous point. And that's all continuous functions really are. But we will talk about limits very shortly.